Kia ora, Year 12 and Year 11. Here are 3 questions looking at long division of polynomials, but there is another way that you can do them using matching up. Now, it's basically the same as long division. I don't know why you would pick it over long division, but if you really don't want to learn polynomial long division, I'm going to show you the other way that we can do them. So these are from a bunch of AS and A-level papers. So the first one is this one: find the quotient and the remainder when x to the power of 4 is divided by x squared plus 2x plus 1. So I'm going to do these 3 questions with long division first, then I'll come back and do the clunkier way. So what we want to do is to set it up like this. We're going to have x squared plus 2x minus 1 out here, and we're dividing it into x to the power of 4. We might as well put in our place value for the other columns. We don't have to in this case, but it's really a good habit to get into, because if we were dealing with, instead of x to the power of 4, something like this, x to the power of 4 plus 7, we'd want to make sure that we'd left gaps for the missing 3 columns. So in this case, all we've got to do is the following. We look at the x to the power of 4 and we say what times that leading term will generate x to the power of 4, and that gives me x squared. So I'm going to go x squared times all of this. X to the power of 4 plus 2x cubed minus x squared. Now I subtract that and see what I've got left over to deal with. And I've got negative 2x cubed plus x squared. Right, so I bring down the 0x and then I move on to the next term. So what times the x squared will generate this thing here? Well, it's going to be minus 2x. So now we have minus 2x cubed. Then I'm going minus 2x times plus 4x gives me minus 4x squared plus 2x. Subtract all of that and see what's left over. So x plus 4x squared gives me 5x squared minus 2x. Right, what times x squared will give me that? It has to be plus 5. So here we have 5x squared plus 10x minus 5, subtract all of that, and we've got left over negative 12x plus 5. So this is my remainder, and this thing here is my quotient. I'm going to do long division on the next 2 now as well. Okay, so to keep this video reasonably short, I'm not going to do the highlighted bit there, I'll just do the long division. So we start off in the same way again. Here we write the divisor, and underneath the division sign we write the thing, the dividend, and we ask what times x squared will generate x cubed. So it's going to be a shorter problem here. So we've got x, and we get x cubed plus x squared minus x. Take it away from what we've got, and we're left with, let's see, 3x squared minus x squared. So we've got 2x squared plus 4 plus x gives me plus 5x. And now I've got the plus 2 from here to bring down. We want to generate 2x squared. We need to multiply x squared by 2. So it's plus 2 up here. And we've got 2x squared plus 2x minus 2, which leaves me with 3x, 2 plus 2 plus 4 as my remainder here. So let's just check that that's what I got when I did it before. Yep, it is. So the quotient is x plus 2, and the remainder is 3x plus 4. Now I said I wasn't going to do that last bit, but let's just have a quick look. Use the factor theorem to show that this is a factor. What I want to do is to work out f of negative 1, and I know already that when I put that in there and substitute it in, look, I've just about done the question. But there you go, we work that out and we end up getting 0. That's how the factor theorem works. Last question, the third long division one, is this one. So we've got x plus 2, and here we've got x cubed plus 30x squared plus 13x minus 25. Right, so we need to multiply by 8x squared. We've got 8x cubed plus 16x squared here. Now we've got 14x squared left. Bring down the 13x. We need to multiply by 14x. And here we've got 14x squared plus 28x. Subtract that. We have negative 15x minus 25. So we're looking for what to multiply by to get the negative 15. So it's going to be minus 15 here. So minus 15x minus 30, bracket, bracket, subtract. And I've got 25 plus 30, which is 5. And I think this was a show that question where we had to show that the remainder is 5. So therefore, remainder is 5. And the quotient is this, right? Quotient 8x squared plus 14x. 8x squared plus, was it plus? Plus 14x minus 15. Now, we've just done 3 of those in under 5 minutes. So I think that shows you my strong preference here is to do polynomial long division because it's really, really easy. But just in case, because I know some of you don't like it, we're going to do it the other way around, which is using the same ideas as long division, but using one massive fraction to do it. So let's have a look at how that goes. Now, this is clunkier. So I'm sure lots of you are going to stop watching at this point, and that's fine. And it's a lot like the idea of completing the square, where we're looking for what we've accidentally taken out. So let's start by having x to the power of 4 over x squared plus 2x minus 1. Draw a big fraction sign, and think about how I can get everything cancelling out with this. Well, you'll recognise exactly the same phrases, right? I'm looking for what will give me x to the power of 4. X squared will. So let's do x squared, lots of this. And then we see, well, what have I accidentally added in? Well, I've got 2x cubed, so I have to take it out. So minus 2x cubed, and I have to add back in an x squared. So that equals, breaking my rule of lining up the equal signs, we've got x squared minus 2, matching up this, 2x times x squared plus 2x minus 1. Now, this is what we want to have here, but what have we got? Well, we've got the minus 2x cubed bit works, but I've got minus 4x, and I want plus x squared, so I'm going to have to add back in 5x squared. Here, I've got minus 2x times negative 1, so I've got plus 2x. I don't want that, I want minus 2x. So let's see what we've got now. Whoops. Now, that shouldn't be over the whole thing. It should just be over this bit. So that equals x squared minus 2x plus, now I'm left with this, 5 times x squared plus 2x minus 1. I've added in 10x, but I don't want it. I want to have minus 2x, so I need to take out 12x. And here I've got 5 times negative 1, negative 5, so I need to add that back in. So that gives me x squared minus 2x plus 5 minus 12x plus 5. So I'm actually going to write that like this. And you can see that's exactly the answer we got to our problem. I think it's far easier to make mistakes doing it this matching up way. I think you're much better off to go and learn polynomial long division. Let's have a look at how we do it in here. Well, very, very similar idea, right? So we have the big fraction line, and we just go through and match. This video is getting too long already, so I'm going to stop there. If you really want me to do some more examples of matching up, send me an email and I'll show you. But for most of you, you should be making sure that you're all good with the long division method. Thanks for watching.